Good morning, PES third graders. This is Miss Jones. It is Tuesday, May 12th, 2020. I've come to chat with you this morning a little bit about our math packets, the instructional resources that were handed out by the school system this week. There is quite a bit of new information and some older information, so we're just going to briefly go through everything so that you are able to complete your packet this week. So we'll just go ahead and get started right away. The topics that were in this packet are probability, patterns, patterns using an input-output table, which is a new concept, and the Olympics information, which involves measurement. So we're going to go ahead and start with probability. Probability we talked about earlier in the year, so it's probably something you already knew about, but we're going to review some key vocabulary so that you're good to do those sheets. So your math packet this week looks like this. The first few pages has quite a bit of probability. The first page is certain or impossible. You have to list the items that are certain or impossible. And then we had this page, probability, likelihood of events. And you had several of those. You had this one, the duck pond, the bags, where you're pulling something out of a bag. And then this is uncertain outcomes. This is with apples, it looks like. Where you have to determine if what the person is saying is accurate. Those are the pages on probability. Now, for probability, there's some vocabulary you need to know, okay? So probability means that we're looking at a situation and trying to determine how possible doing a certain thing would be. So if we're looking at this box and we were going to put our hand in without looking and reach in and pull out a letter, what could our outcomes be? Our outcomes are we could pick the letter A, we could pick the letter B, we could pick the letter C. Okay? Those are only three outcomes. When we look at the word outcome, outcome just means what are your different options that you could pick. So that word outcomes is just what are the different things that could happen. Okay? So now we're going to look at some words like certain or impossible. Okay? When something is certain, it's going to happen every time. So one thing we could say here that would be certain is we are certain to pick a letter from the box. We're certain to pick a letter. Every time we reach in and pull something out, it's going to be a letter. So that is certain. It's going to happen every time. Okay? When we say something is impossible, that means it's never going to happen. If I reach my hand in this box and pull something out, I'm never going to pull out a number. I'm never going to pull out a shape. Every time I reach in, I'm going to pull out a letter. So we would say that pulling a shape or pulling a number would be impossible. Okay, the word impossible means it's never going to happen. The word certain means it's going to happen every time. Now, we'll also see the words like likely or unlikely. Okay, or we might see the word most likely. Okay, looking at this box, we can see that we have 2 A's in the box. We have 4 B's in the box, and we have a C in the box. So the most likely thing we're going to pick is the one that occurs the most. Most likely, it occurs the most. So we're most likely to pull a B. We're least likely, that's the thing that's going to happen the least amount of times. We have the least amount of things that occur are the C. So that's the least likely thing to pick. That doesn't mean it won't happen. That means we're least likely to pick it. I could reach in and pick a C out the first time, but that's not what you would guess would happen because there's only one C. So most likely is going to be the thing that occurs the most. Least likely is going to be the thing that occurs the least. Okay? Sometimes we talk about equally likely. Okay? If I added 2 more A's here, okay, we would have 4 A's and 4 B's. Those 2 outcomes would be equally likely. That if we were going to pull letters out, we would be equally likely to pick an A or a B because they both occur an equal number of times. Okay? So just look at, when you're looking at most likely, least likely, and equally likely, just think what occurs the most, or what occurs the least, or what occurs an equal number of times. Okay? All right, remember the word outcomes is just what are all the possibilities that you could pick. All right? Certain, always going to happen. Impossible, it's never going to happen. All right? Okay, so that should help you to do those first few pages. Now, looking at, that should be pretty easy. So here, what I would do for this one, the duck pond, it says pick the golden duck. Mr. Mitchell's class runs a game at the school carnival called Pick the Golden Duck. People who play the game must put on a blindfold and then pick one duck out of the pond. The ducks are of equal size. Okay, so you're going to color your ducks based on what it says. So it says there's only one duck, one golden duck. So you're going to color one golden. Picking a blue duck is more likely than picking a golden duck. Okay, so there's going to be more blue ducks than gold. But picking a red duck is more likely than picking a blue duck. So when you color them, one golden, more blue than gold, but then you have to have more red than blue. And then picking a green duck is more likely than picking a red. So you got to have the most green. So once you color those that match those sentences, you'll be able to answer these. Don't try to answer these without coloring your ducks first, okay? Because that's going to be, that is going to be your best bet to do it. Don't worry about these words in here. Okay. Next page should be fine. Next page should be fine. All right, so the next thing after probability is patterns, okay? We've done patterns a lot here at school. You've been doing patterns really for a couple of years. Patterns, when we look for a pattern, a certain pattern, we need to look at what's happening to get from one number to the next. So they give you this example up here, okay? They give you this example of we go from 2 to 5 to 8, then we have a blank, to 14 to 17. And then they just start figuring out, well, to get from 2 to 5, I have to add 3. To get from 5 to 8, I have to add 3. And so they're assuming that to get to the next number, we're going to add 3. So 8 plus 3 would be 11. Okay, 11 plus 3 is 14. 14 plus 3 is 17. And then we're going to add 3 to the last one. So the last number would be 20. 17 plus 3 is 20. So you have to look at what is happening each time in order to get to the next number. Okay, so you should be fine with that. We've been doing a lot of that at school this year. But the thing I really, and the next page, same thing. Whoop. You're looking for the pattern. What are the numbers doing? How are we getting from 93 to 87? What do we have to do to get from 93 to 87? We can count backwards, right? Because the numbers are going backwards. We're going to go from 93 to 87. 93 minus 6 equals 87. I'm going to take these pages off that are before it. We're going to minus 6. So let's see if that works to keep going, because sometimes the pattern changes. So we're at 87 now. How do we get from 87 to 81? We get from 87 to 81 by minus 6. Count back on your fingers if you need to. 87, 86, 85, 84, 83, 82, 81. That's 6. Okay? How do we get from 81 to 75? Same thing again. We're going to minus 6. So since we've done minus 6, minus 6, minus 6, we're going to assume that to go from 75 to the next number, we need to minus 6. So 75 minus 6 is 69. Okay? And then 69 minus 6 to get to 63. And then you'll just keep going. What's the next number going to be? 63 minus 6. Our rule is minus 6. So we keep doing that. Okay? All right, the next thing I really want to take some time to go over because it is input-output tables. Okay? Input-output tables are new for the most part. I think we did a little bit of it when we were adding and subtracting, but it's been a while. So let me get a drink real quick. Sorry. Input-output tables. Think of an input-output table like a big machine. Okay? We have a number. We put it in a machine, and it comes out a different number. So we have to figure out what happened in the machine to make it come out another number. It's just like patterns. Okay? Are we adding to it? Are we taking away from it? What number are we adding or taking away from it? Okay? So I have an input-output table right here, and it doesn't give us the rule. Sometimes it'll give us the rule. Sometimes we have to figure out the rule. For this one, we're able to figure out the rule. The input column, that's what we're putting into the machine. We're inputting it into the machine. And then the output is what's going to come out. Okay? So, is this backwards to you guys? I hope not. Okay. So input-output table. So if we put in 15 into the machine, a 19 comes out. Okay? We put a 15 into the machine, and a 19 comes out. So what did the machine do? How do we get from 15 to 19? 15, 16, 17, 18, 19. When we put the 15 in, it came out a 19. So what did the machine do? It added 4. So we think that the rule is plus 4. Let's see if we're right. They give us another example. We think the rule is plus 4. So let's see. If we put 22 into the machine, it comes out at 26. How do we get from 22 to 26? 22, 23, 24, 25, 26. Plus 4. It's following the rule. So we can say it's not a question mark anymore. The rule is add 4 for this input-output table. We're adding 4. We put a 15 in, comes out with a 19. We put a 22 in, it comes out with a 26. Uh-oh. Now we have to figure out what number are we putting in for it to come out a 34. It's coming out a 34. So while it was in the machine, it had 4 added to it. So we got to go backwards here, right? So what can we put in to make it come out a 34 if the rule is add 4? A 30, right? Because 34, 33, 32, 31, 30. If we input a 30 in the machine, it adds 4. It would come out a 34. All right, this one will be easy for you. 49. If we put a 49 in the machine, and the rule is add 4, how do you get from 49? And then we're going to add 4 to 49. 49, 50. Did you get 53? Yes, if we put a 49 in the machine, and our rule is add 4, it'll come out of 53. Now this last one, they give us the output. So it's coming out of 55. While it was in there, it had 4 added to it. So we're going backwards. Okay, so what did we put in? If we're at 55, we got to count backwards to find out what we put in. Did you get 51? 55 minus 4 is 51. So if they give you the output, you have to do the opposite of the rule to get the input. Because 51 plus 4 is 55, right? If they give you the input, you can just do the rule. All right? Does that make sense? So input-output tables mean that they're going to give you a number, okay, and some sort of rule. And so you're putting the input number into the machine. It's going in a big machine, kind of like a calculator. And whatever that rule is what's happening in the calculator, and then the output is what's coming out the other side. So think of it as a big machine. You put the number in, whatever the rule is happens to it, and it comes out the other side. So you've got a couple pages like this. You've got this page, patterns in tables. Same thing, input, output. Okay, they input 62, and it comes out of 57. They put in a 58, it comes out of 53. They put in a 47, it comes out of 42. What's the rule? How do we get from 62 to 57? That should be the same as putting in a 58 and getting out of 53. Putting in a 47 and getting out of 42. What's the rule? Okay, you're going to write the rule down here and then finish these two up. Do the same thing over here. Okay? All right, the next page is the same. Some of them give you the rule. Some of them do not. They just give you some examples and you have to figure it out. All right. And then this page is the same thing. They give you like real life situations and you have to complete the input-output table. So I'm going to do one of these with you. All right, the first one says scenario A. One bicycle has 2 wheels. 2 bicycles have 4 wheels. Continue the pattern on the table. Name the rule. How many wheels would there be on 7 bicycles? So you're going to use this page to do this. All right. So scenario A says 1 bicycle has 2 wheels. Okay. So 1 bicycle, you input 1 bicycle, and it has 2 wheels. Okay. 2 bicycles have 4 wheels. Continue the pattern on the table. Name the rule. How many wheels would there be on 7 bicycles? So we have to figure out what's the pattern. So let's keep going with the pattern. So how many bicycles would there be on 3? How many wheels would there be on 3 bicycles? Okay, bicycles have 2 wheels. So if we have 3 bicycles, we have 2 plus 2 plus 2, which is 6. Good. So what's our rule? What's our rule for this table? If we input a 1, we got out a 2. So it could be, okay, plus 1's our rule. But then when we come down here, 2 bicycles have 4 wheels. That's not plus 1. The rule plus 1 won't work. What about here? 3 to 6. Does the rule plus 1 work? Does a rule plus 2 work? No. So it's not a plusing pattern, but our number is getting bigger. What other operation can we use in math that makes a number get bigger? We know subtracting makes it get smaller. What about multiplying? If we have 1 bike, it has 2 wheels. So that would be 1 times 2. Let's see if that works. Let's put times 2 up here, see if it works. 1 times 2 equals 2. What about 2 times 2? Is 2 times 2 4? I think it is. 3 times 2? Is that 6? I think our rule is times 2. So our rules don't just have to be adding. Okay. So it asked, how many wheels would there be on 7 bicycles? So we're not just going to keep going in order. Okay. Let's do 7 next. We don't have to do them all the way down. We don't have enough spots. So if we input 7 bicycles into the machine, and our rule is times 2, how many wheels are coming out? What's 7 times 2? 2, 4, 6, 8, 10, 12, 14, right? If we put 7 bikes in the machine, 14 wheels should come out because we've got to do our rule times 2, right? So that's what you're going to do here. You have to look at the real world situation from this page and apply them here. Okay? All right, so that is input-output tables. Just remember with all your input-output tables that you're taking a number, you put it in a machine, and out comes a new number. And you have to figure out the rule. Okay, so the next page is directions for making an input-output machine if you'd like to. Okay, that would be kind of fun. Input-output machine. If you put a number in, what number comes out? All right, if you want to do that at home. And then you have another sheet of input-output practice. Okay, I put in the number 50. They give you your rule, subtract 5. I'm going to get out 45. 50 minus 5 is 45. You have to finish. All right, some of them give the rules, some of them you have to figure out the rules. Okay, so you have that to do. And then the last thing is some Olympics. It says the Olympics. It gives you some history of the Olympic Games. And then you have to do some Olympic practice at home. You get to do some activities with some items you might find around your house, okay? So the first page is just some information about the Olympics. The second page starts the actual Olympics. You get to do a javelin throw, but instead of throwing a big javelin like they do in the Olympics, you're going to throw a paper straw and then measure how far your straw went. Paper plate discus, if you have a paper plate at home. Now throw it like a discus and see how far it goes, and you'll measure the distance, okay? And you have some other things. A cotton ball shot put. You have a marble grab, sponge squeeze, and Bigfoot was here. I guess you have to measure your foot, okay? So these are some activities you can do for the Olympics. The next page you may have to alter a little bit, okay? This page, what you're doing here is you're measuring some things, okay? You're going to measure first your hand span. So from side to side on your hand, you have to measure how big it is, how long it is. And they give you the units millimeter, which we really haven't learned much about. So if you want to do it in centimeters, you can just change it to centimeters. You can change these units. Down here, 1 through 4 in the second section, they have the letter G for grams. That's the unit they give you. Change that to pounds. LB is the unit for pounds because we measure things in pounds. The next section is milliliters. You're measuring in milliliters, which I don't even understand how you measure a block of wood in milliliters. That doesn't make much sense. So measure these things in units that make sense to you. I don't want you getting upset or worried because the units are not making sense to you. These are not necessarily the units we learned here in 3rd grade. So I want you to change them, especially this section and this section. Change them to units that you know, okay? And that is fine, just like Miss Jones did here. In fact, this next section, if you want to copy mine, pen cap, I would probably measure the length of that, and I could do that in inches. Paper cup, I could do that in inches. Your fist, I can measure my fist in inches. And a block of wood, let's do that in inches too. So, and if any of these things you don't have around your house, that's okay. Just skip that one, or you can change what you're measuring too. Change it to something you have. So I just changed this whole section to pounds, the second section, and I changed this section to inches. Okay, just to make it usable for us, what we use. And this inches will be on your ruler, centimeters will be on your ruler. Over here, they give you some units. So they say, okay, 40 centimeters. So you're going to look on your ruler. Look what 40 centimeters looks like. And I want you to try to find an object around your house that's 40 centimeters. And then the next one's 87 centimeters, 3 centimeters, okay? So you can look at your ruler first to see what does that look like. And then go ahead and find an item around your house that looks like that. I know this was a lot of new stuff today, guys. If you have any questions at all, don't hesitate to email me or email your math teacher or your homeroom teacher, and we can help you out in any way you need to. But have fun with this, at these activities. They are kind of fun. These topics are more fun than some. So enjoy it. Don't worry if you have to change something a little bit to make it work for you, especially with the Olympic stuff, with stuff you find around the house. We miss you. We can't wait to see you guys again, and I hope you take care. Bye, guys.